Afternoon, everybody. Good afternoon, participants. You are all very welcome to this afternoon's meeting. If I'm audible, can I get some feedback? Hello. Thank you very much, guys, for the feedback. So we'll be beginning our afternoon session very shortly. And so you're all very much welcome, distinguished SP members, non-SP members, and everyone who is joining us for the first time as well. This is SB Ghana, and this is a special session, a technical specialization dialogue, captioned subsea and completions under the Career Guidance and Outreach Committee of SB Ghana. And so this afternoon, we are having a technical session, and so I would like to just give a brief introduction about what the meeting is about. We want to help professionals, young professionals and students to grab the intricacies of each role and how they can also find career opportunities as well and position themselves for the near future as well. And so basically we'll be looking at understanding the distinction between the roles that we find ourselves looking at today, that is subsea and completions. We want to look at their distinctiveness as well and also explore some of their different connections and how they interact with each other. So I'm sure we are all poised up for a very educative ride this afternoon. And as we proceed, we would want to indulge that each and every one of us would pay key attention to what will be being said today or what we'll be studying today. So before we begin, I'd like to lay a bit of housekeeping rules for us to note so that we can have a very seamless meeting for our distinguished speakers and all participants as well. So kindly mute your microphones, and also we'll have a session, a Q&A session where each and everyone can ask questions. And so you would have to use the raise hand icon if you have any questions. And all contributions can also be made in the chat box as well. Thank you very much once again for your patience. My name is Agla Marvin, and I'll be your moderator for this afternoon session. So before we begin the meeting, I'd like to outline what exactly we are in for. And so just a brief outline about our program this afternoon. We are going to have a welcome introduction, which I've briefly done, but we'd have an opening address, and I'll be introducing the person to do that in due time. We'll have the first presentation, the second presentation, then we'll move over to a cross-questioning session, and then a Q&A session. I'll be leaving a feedback survey in the chat box for us to fill right after the program so we can access the program and make it better the next time. We'll have a vote of thanks as well by the end of the program. So we'd like to proceed to the business for the day and a very important segment for this afternoon session. But before we do that, we would have a welcome opening address by one of our distinguished own in person of Akosia Bando, who happens to be the Deputy Career Guide Outreach Chair for SP Ghana. But before we do that, we would want to have an icebreaker session. As I said, all work and no play makes Jack a dull boy. And we want to just find out if most of us are really following what's happening in SP or if we have some knowledge about SP Ghana as well. So you can leave your answers in the chat box as well. I'll be reading out the winners for this icebreaker session. We'll be asking a few questions to know whether we are really familiar with SP. So if we are all available, the first question is, which institution was crowned the 2025 SP Ghana Petro Bowl champion? That's the first question. And so you can leave your answers in the chat box as I read them. Which institution was crowned the 2025 SP Ghana Petro Bowl champion? I'm sure most of us are familiar with this. And so if you have an answer to the question, you can leave the answer in the chat box. And I would be reaching out to our winners. Okay, I'm getting a lot of answers right now from the chat box. Interesting answers. I'm seeing the same answers. I have 3 responses. Okay, so I'm seeing University of Mines and Technology. And so our first winner, we have Elsie Putet Sapak happens to be the winner, and she had the answer correct. That is University of Mines and Technology, UMAT. So Elsie, we acknowledge you, and we can give her some reactions in the chat box as well. To our second question, can you mention any other SP sections apart from the Ghana section? Any other SP section apart from the Ghana section? Okay, we have the first answer. Any other SP section apart from the first section? And you'd have to be specific with the section as well. Any other SP section apart from the Ghana section? Okay, I'm having one answer. That is the Lagos section. Thank you very much for that answer. And so we have the Lagos, Port Harcourt, and Burkina happen to be in the sections for other sections in SP. So our final question, who is the current SP programs chair of SP Ghana? Can you kindly name the personality who happens to be the current special programs chair of SP Ghana? We had a late answer from the previous question, Angola session. Thank you very much for that answer. To our next question, who is the current special programs chair of SP Ghana? This is a quite tricky one. If you have been following SP events, you should get this one. Who is the current programs chair for SP Ghana? The time is going. If we have no answer, okay, we have an answer. We have Fifi Nyanko Uto happening to be the special programs chair. Thank you very much for that answer. Very wonderful. And so now to the end of our icebreaker session, we are now moving on to the business for the day. We want to have an opening address by Akosia Bando, who happens to be the Deputy Career Outreach Chair for SP Ghana. Thank you very much, Akosia. If you are available, the floor is yours.
Thank you very much, Marvin. Good afternoon, everyone. And I would like to say a very big thank you to all for making time to join us today. Today, as Marvin mentioned, there's a technical specialization dialogue on subsea and completions organized by the Career Guide team of the Career Guidance and Outreach Committee of SPE Ghana. And it's a great pleasure to have you all join us to what really promises to be a very insightful and engaging session. I would want to welcome our distinguished guests who were able to join in. I see that so many people have taken time off their work and their busy schedules to be gathered here to listen to this webinar. I can see that my co-chair, Mr. Samuel Tete, is here, and as well as all the various committee leads who have been able to join. And this particular event means a lot to me because I've had the opportunity to work directly with both of today's speakers, and I can personally attest to their exceptional and technical skill and their deep knowledge in their respective fields. And I know that everyone who has been able to join would be so much informed today. And I'm confident that we will have very much great value from today's session. So we are all honored to have Mr. Joseph Pongo and Mr. Enoch join us Mr. Enoch Somayade from Talo, whose insights will definitely speak for themselves. I know we can all attest to that after the session. And so whether you are here exploring a career in subsea or completions, or you're just here to learn about the industry, I can attest that you're in the right place. And so thanks to everybody. And also a big thank you to the Career Guide team, Mr. Daniel Opon, Mr. Stephen Foucault, and the entire Career Guide team. Marvin, thank you as well for leading and putting this together. I encourage all of us to be keenly involved, ask a lot of questions, and make the most opportunity of the session today. So thank you all once again. Over to you, Marvin.
Thank you very much, Akusia, for that wonderful speech. We are also looking forward to a very great technical session. And so we'd like to proceed to the business for the day. I want to proceed to the introduction of our speakers, our distinguished speakers for this afternoon session. Now, I once again want to caution us to kindly mute our microphones and let's ensure we have a very seamless session. You can leave or drop your questions or concerns in the chat box as well. And so we have the profile of our first speaker in person of Mr. Joseph Achupongo, who happens to be an offshore field manager at Talo Oil. So just a brief profile of him. He has over 16 years experience in the oil and gas industry. Mr. Joseph has built a distinguished career specializing in subsea construction, installation, and FPSO operations. His expertise spans major offshore projects across multiple regions, demonstrating a strong technical foundation and leadership in deepwater operations. He spent 8 years at Technip FMC Houston, playing a very key role in several high-profile turnkey, turnkey projects. Some of his portfolio includes Nobles Energy Tamar and Leviathan projects in Israel, BP's Quad 204 and Galeota projects, Shell's Cardamom, Princess and Kaikias projects in the Gulf of Mexico, Chevron's Blind Faith project, Anadako's K2 project, BP's Juniper project in Trinidad and Tobago, PVDSA's Dragon project in Venezuela, BG now Shell Starfish project, Trinidad and Tobago, and Talo Jubilee and 10 field projects in Ghana here, among others. He currently serves as the 10 FPSO offshore field manager at Talo Oil, a position he's held for the past 2 years. Before assuming this role, he contributed significantly to Talo Oil subsea operations as a subsea execution manager and subsea operations manager. He's also been instrumental in optimizing offshore field development and subsea infrastructure management. His extensive experience, strategic leadership, and technical proficiency continue to make him a valuable asset in the oil and gas industry, particularly in offshore and subsea operations. So once again, you're welcome, Mr. Joseph Pongo, and over to you. We are ready. If you're ready, you can present now. Thank you very much.
Okay, all right, thank you. So for my icebreaker, let me turn on my camera. Okay, so I am offshore. For those of you who actually see my background, you can tell I'm offshore right now. So my personal icebreaker is to pick on Akusia. So Akusia, our mutual friend, keep asking of you. Um, Now going back to the business of the day, I had an interesting conversation with one of my colleagues here this morning. So he walks to me and then he says, "Well, the last session that I led. Well, I don't know if led is a correct word, but where I presented for both SP and Ghana Institute of Engineers, that the topics it was interesting, but he got lost quite a bit. So I'm interested in knowing. I think the last time I checked, we were about 17 people here. How many people on here can you show by raising your hand? How many of you here know something about subsea? just to gauge my, so I know my audience, and I know how deep or otherwise I should go with my very brief, I don't know if I should say speech or whatever it's called. So can we tell by show of hand how many people know something about subsea? Or maybe I should reverse it. How many people know either nothing or very little about subsea? That might help. Marvin, I don't know if I'm missing a screen, but is anybody responding on this now?
Presently, no one has responded yet.
Okay, well then I'll go ahead. So subsea, it's one of those areas that in a typical Ghanaian space, if you tell somebody you're a subsea engineer, the first thing they ask is what? Because it's not something that is widely known to a lot of people. If you look at, just take offshore, don't even think about oil and gas. So if you're offshore, you have ships, vessels that sail on either rivers or on the ocean. And if you take marine engineers, their primary focus is to ensure that whatever they put on the surface of the water doesn't sink, it floats. That is as simple as that. Regardless of what kind of structure it is, the intention is to keep it afloat. Now, when you come to subsea, the intention is opposite. For a subsea engineer, the intention of everything we put in the water is for it not to float, for it to sink. And then when we say sink, we want it to sink and be stable on the seabed. So if it happens to be through the water column and you'll be hearing words like risers, we'll talk about them later. But anything any structure you are landing on the seabed, you want that structure to be stationary at one location. I am deliberately not sharing any screen because I want us to actually exercise our imagination quite a bit today. So imagine you are home, and I'll try to use things close to us. So you are home, and you have Enoch is going to talk about completion, so that will be in the well. You have a borehole at home. Now, that borehole, obviously, the intention is to produce water. So you have your water coming out of the borehole, and then you lay your PVC pipe, from the borehole, the top of the borehole, all the way into your poly tank. And then from the tank to your home, to the sink and WC and all the good stuff, the kitchen sink and all that. Now, for some on this call, I'm sure you have things between your poly tank and your home, like a booster pump. So you are able to maintain good pressure. So whenever you actually open your tap, you have water flowing to you. Now, if you think of some of these things and you bring them to the oil and gas space, on the seabed, and since we're talking about subsea, so I know wells are not only drilled offshore. We have onshore wells, but we're not talking about onshore. We're talking about offshore. So you have your well drilled, you have your Christmas tree sitting on top of your well, and how do you get your oil or gas from that well all the way to the FPSO or any other production facility that you have? So you have your pipeline, similar to the analogy I just gave in the case of a borehole, right? And there are so many infrastructure that actually comes to play between your well and then coming to the FPSO. If you think about it, you are dealing in an environment which is very corrosive, seawater. So we all know what happens when you actually have seawater in contact with any kind of metal. So as an engineer, you now have your work being cut out for you. You need to design your structures to actually withstand the kind of environmental conditions that your structure is going to live in. So the corrosive nature, that's the seawater. Depending on how deep you are going, you can have your structure at any kind of water depth, from shallow waters all the way to deep waters and ultra deep waters. These days, deep water definition keeps changing. Here in 10, for instance, we have the deepest is 1,800 meters. So 1.8 kilometers deep is the deepest we have here. You go to other regions, you go beyond 2,000. At the moment, I think the deepest that's been qualified for oil and gas is about 3,000 meters. even though there are qualifications to actually go beyond that. So imagine the pressure that you are actually exposing your subsea infrastructure to at that depth. Now you need to design your structure such that your structure does not implode. I hope we all know what implode means. Explode is when the force causes your structure to, as it were, disintegrate. Now you're actually basically caving in, just out of the sheer environmental, pressure your structure is being exposed to. You are going to your crude. You could have salt crude, sulfur, the various, you know, the various elements that are going to be in the crude. You need to design your structure such that you're able to withstand all of them. Now, if you have a structure on the seabed, 1,800 meters, how do you control it? How do you control your well? If you want to shut in a well, what do you do? So you hear things like an umbilical, which just like a mother and a baby, the umbilical cord, that's the mother, that's a means by which the mother is able to feed the baby, right, in the womb. So the umbilical is how chemicals, hydraulic fluid, and electrical and fiber optics signals are sent from the top side all the way to your various structures. So there is a very diverse number of elements that actually come to play when we talk about subsea. Now, if you go to the hospital and someone says, I'm a doctor, the first question you ask is, what kind of doctor? Are you a dentist? Are you a gynecologist? Are you an orthopedic doctor? The eye doctor, optometrist? I hope I got that word right. There are so many different specialties that you find in the medical field. And the same thing happens in subsea. So you have people whose specialty is actually construction and installation engineering. And then they are the guys who actually come up with all the crazy ideas of the client wants to do A, B, C, and D. Okay, well, these are the things that I need to actually do them. We need to design a structure of this nature. We need to get a vessel of this capacity. That gives you an idea of what a construction and an installation engineer does, all the way through to the installation phase. Then in between that, there are so many other disciplines. You have your structural engineer, and he's a guy the design parameters being provided by the client and the project engineer. The structure is able to withstand all of those. You have your analysis engineer who does, because if you imagine, for those of you who've never even been offshore, when you watch movies and you see how rough sometimes the sea can be. So you are deploying a structure to go through the water column to get all the way to the seabed, and it's going to be exposed to all these massive forces. And you want to ensure that in the process of deploying your structure, you do not end up actually damaging the structure. You do not want to have undue stresses being induced in your structure where whilst you finally landed your structure on the seabed, the stresses are now causing other issues with the structure. And those issues could potentially even result in a reduction in the, how do you call it, in the life of your field. So your analysis guy comes in and then gives you all that guidance. Okay, well, you cannot deploy this structure when the sea state is beyond this limit, when the wind speed is this, when the waves are this, all that good stuff. And then that guides you, that guides the installation engineer when he goes offshore. You have your controls guys, and the controls guys are probably these day and age Gen Zs who are interested in a lot of this technology stuffs. So when you need to function a particular well or a particular structure, a valve, or any structure on the seabed, how do you actually get to them? Imagine your phone. I'm sure there's nobody on this call who would want to put your phone in water, even though iPhone will tell you, Apple will tell you, you can dip your phone in, I don't even know how many meters deep for about 5 minutes, but nobody wants to do that. And then here we are putting smart kits all the way, sometimes 1,000, 1,500, 2,000 meters deep. And then you have to design these such that even though they are going into the water, they are not supposed to be touched by water. They are supposed to be insulated, properly insulated. You cannot have any kind of basically, there cannot be any kind of moisture contact to any of these cars, else you short circuit them and then you blow them up. Keeping in mind that whatever you are installing, you design these for a minimum of 20 years. So the intention is whatever you're designing goes on a seabed, it stays there for 20 years with minimal and for most occasions, no maintenance. So the controls guys come in. Then talking about maintenance, you have your maintenance and integrity guys who also comes to play here. Obviously, with time, they need to ensure that your structures are healthy, carry out periodic inspections, different types of inspections with the ROV, and specialty tools depending on what you're looking at. And then that also gives you an idea of the health of your structures. So if you are beginning to experience any issues, then your construction and installation guys can now go ahead and plan remedial actions to resolve these issues. You have your flow assurance guys. You are flowing oil and gas. You want to ensure that your lines are constantly clear. So how do you ensure that there are no blockages in the line? Hydrate formation, wax deposition, asphalting. So basically, you need to understand the parameters within which you can operate to ensure that your lines are free to flow at all times. And this is where your flow assurance guys come into the picture. So that gives you an idea of the various subsea disciplines, the various disciplines when you talk about subsea. You have people in the field who provide, if it's a production facility, they provide production support, ensuring that the equipment on the top side that controls your subsea infrastructure are healthy, monitoring all the operating parameters, and if any of the parameters appear to be going off, they have to troubleshoot to understand what is causing the problem. Oh, sorry, someone says my voice is diminishing. Is it any better?
Yeah, all loud and clear.
Okay, all right, good. So the topside equipment that are actually going to control your subsea infrastructure, ensuring that they are healthy. If there happens to be any issues with any of them, troubleshoot to understand what the problem is, and then map out together with the construction and installation guys the remedial actions to implement. If you go to the rig, you have subsea guys on the rig, because obviously the rig, they're also dealing with infrastructure that's they're actually landing on the seabed to help control the wells and all that. Enoch may touch on some of them. You go on a construction vessel, you have the subsea guys there who are basically providing technical support to the crew offshore, ensuring that structures are being deployed and then landed and handled as per procedure, as per approved procedure, and as per industry standards. So there are so many different aspects of subsea, and I hope this gives an idea of subsea. Now, if I start talking about subsea, I can continue for about 2 hours. So, Marvin, I think I've gone beyond my time. I am guessing that there's going to be a lot of questions, I hope. So I will attempt to address them as and when they come along.
Okay, thank you very much. Thank you very much, Mr. Joseph. Quite some insightful insights there from a lot of us that are watching or onlookers. And we actually are learning a lot of new things today. Most of us, or let me say, quite a number of people were not familiar with what happens subsea, and because some said they had no idea. But you quite give us an insight as to construction engineers, flow assurance engineers, analysis engineers, and how these roles interconnect and come together. I'm sure you share more insight on that as we move on. And an interesting insight was also the fact that you said marine engineers and subsea engineers. I'm sure there were some similarities between the roles, but thank you for the insight. I'm sure you will do further insight with that as we move on. So we'd like to move on to the second part. We'd like to move on to the second part of our, and we want to introduce the next speaker that is coming up. We'd like to introduce Mr. Joseph. Sorry, Mr. Enoch Asumia. We want to introduce Mr. Enoch Asumia Adai. And so I want to read his profile as we begin. So Mr. Enoch Asumia is a highly accomplished professional. Sorry, he happens to be a senior well completions engineer at Talo Oil as well. And he's a highly accomplished professional with a robust background in petroleum engineering and procurement. He had his high school education at Infante Pim School, graduating in 2005, and later earned a Bachelor of Science in Petroleum Engineering from Kwame Nkrumah University of Science and Technology in 2010. In 2016, he further enhanced his expertise by completing the Fenley Proctor Well Engineering Competency Program in the UK, specializing in tubing design, completion design, and well control. Most recently, in 2024, Enoch obtained a diploma in procurement and supply from the Chartered Institute of Procurement and Supply in the UK. He started his career as a tutor with the Ghana Education Service, teaching chemistry and integrated science at the senior high school level from 2010 to 2012. He then transitioned to the oil and gas industry, joining Tallow in 2012. Over the years, he has progressed through various roles, including trainee engineer, well site completions engineer, and then completions engineer as well, and then a senior completions engineer. He's also a chartered engineer with the Ghana Institute of Engineers and a member of the Chartered Institute of Procurement and Supply in the UK. He combines his technical expertise with practical experience. Aside that, he's also a family man. I mean, he has, aside his professional commitments, he enjoys table tennis and gardening at home as well. So you're welcome, Mr. Enoch Sumia Adai, and we are ready. If you're ready, the floor is yours. Thank you very much.
Yes, thank you very much, Marvin. So I would like to share a few slides. Please confirm if...
You can do the sharing, please.
Okay. Okay. Can you confirm you can see my screen and you can hear me?
Yes, please.
Well,
your screen is visible and we can hear you as well.
All right. Thank you very much. So before I start, I would like to thank the chair and the organizers of this program for bringing, professionals to your doorstep and making them available, for questioning and advice. I remember when I was considering, enrolling on the petroleum engineering program some years back. It took quite a considerable effort, from my part to get in touch with one of the students at the time, to seek advice. So doing this, it deserves an upload, and thank you very much. So I would cover completions. I will talk about what a completions is. I would explain the role of the completions engineer during the various phases of the well delivery process. So I'll start from the concept, go through planning, design, up to operations, and at each stage, look at what the completion engineer is responsible for. And I would talk briefly on some of the career options within petroleum engineering. So over here, I just wanted to explain the various core branches within petroleum engineering. So petroleum engineering is really broad, and within it, there are four core specializations that you could go into. So starting with reservoir engineers, these guys are responsible for estimating the amount of hydrocarbons that we have in the reservoir rock. They come up with plans to economically develop the field and also recover hydrocarbons from the earth. They work hand in hand with geologists and other professionals to decide on the exact location where a well is to be sited. So reservoir, if you talk about reservoir, I want you to imagine it with this way. It's like a huge beehive, and you all know how a beehive looks like. There are, what do you call it, pores all around the beehive. So the rock is just like that, and the spaces or the small pores that you find on the beehive, that is where the oil and gas, reside in. Now, so once the reservoir guys have, together with the other professionals, have decided where to drill, we have the second group of professionals coming in, and their task is to take the surface location and the subsurface location that has been defined by the reservoir guys, and they are responsible for digging a well that intersect those 2 points. So it sounds very easy, right? You are given 2 points, and all that you really have to do is to dig a well or make a hole that would intercept those 2 points that you've been given. Now, after each section, each whole section has been drilled, these guys will now drive or push large steel pipes into the ground, and this is to prevent the hole from caving in. Then we now have the third group of people who are the completion engineers. So basically, once the well has been drilled, completion engineers come in, and all that they are doing is that they are, imagine you have 2 large tanks, right? One is underground and one is also on surface. And the role of the completion engineer really is to sort of connect these 2 large tanks with a pipeline, so that we can transfer or move fluid from one point to the other. So if you think about it, the reservoir is your underground tank, and we have the surface tank, which could be a temporal storage on the rig, or it could be an FPSO. And what the completion engineer does really is to move fluid from one point to the other. Joseph has touched on subsea. Basically, that is from the seabed all the way to the FPSO, all the infrastructure that you have in place, that would be subsea. For completions, we are interested. Our job ends at the Christmas tree, which would be put on the seabed. So basically, we are putting pipes in the well, which would connect the reservoir to the Christmas tree on the seabed. The fourth group of people is the production engineers, and these engineers manage the daily production rate from the wells and ensure that hydrocarbons are recovered in the most efficient way. So basically, they control production rate in such a way that you don't produce too quickly, so as to deplete the reservoir pressures, and you also have to produce in an optimal way, in such a way that you are able to meet your production target. Okay, so moving on to the next slide. So over here, I have a very simplified diagram of how the well looks like when it is handed down to the completion team. So on your left, we basically have a hole drilled into the earth, and you can see some strings of pipes, which we call the casing, run in place, and these casings, have been cemented. You can see, I don't know if you can see my cursor, but over here, we have what we call a suspension plug, which is used to suspend the well before we come in to start our operations. So basically, when we come in, we recover the suspension plug, and we now install steel pipes, smaller steel pipes, which are called tubeless or tubings, and we also install specialized equipment and tools in the wellbore. So on the right, that picture there really shows how the setup looks like during the operational phase, right? When there is a rig in place, and we are installing, or we finished installing the completion. When we hand over the well to the production team, the rig will no longer be there, and the section of pipe in the water will also not be there. And in place of that, we would have the Christmas tree on top of the wellhead, like Joseph explained. And basically, that is the role of a completion engineer. He converts a drilled well into a safe production or injection conduit. Yep, so we've touched on some of this. Completion follows the drilling phase, and it involves the design, selection, and installation of tubings, tools, and specialized equipment into the wellbore. And these provide a flow path, to enable us to produce hydrocarbons from the reservoir to the Christmas tree, or to be able to, inject gas or water into the reservoir to support production. Yeah, so over here, I wanted to talk briefly about some of the data or information that the completion engineer works with. So starting with reservoir, the completion engineer needs to understand what type of reservoir rock he's going to be working with. Is it a sandstone reservoir? Is it a limestone rock? What is the strength, of this rock that is going to be completed? Are the grains in the rock properly cemented, such that when production start, we are not going to produce sand, and we are not going to have fines into the wellbore? Now, depending on the strength of the rock, right, it will determine whether the completion engineer now has to, design a well which has a sand control in place, or the rock is very strong, such that we can do with a simple open hole completion. The completion engineer also needs to know what the reservoir pressure is. Fundamentally, all the design work that he does is going to be influenced by the pressures that exist downhole, right? So he needs to understand that pressure, and it basically forms the basis, of all the design work that is done afterwards. So things like calculating, brine weight, and deciding on which sort of brine to use in the well is all dependent on the pressure. We also have to, understand reservoir temperature. Okay. Downhole, what is my temperature at the bottom of the well? On the seabed, what is my temperature there? Temperature also affect all the design work that the completion engineer does. As you would know, temperature affects the strength of materials. It affects how seals and elastomers work, and the engineer, needs to know all of this to take these into consideration when designing his well. On the production side, the engineer needs to understand the length of the length of the reservoir section that is going to be perforated. And perforation simply means running guns into the wellbore and shooting the casing to create holes in the casing through the cement behind the casing, and also to shoot into the reservoir. And perforation provides, what do you call it? It allows you, it creates holes in the casing and makes it possible for the fluid to move from the reservoir into the wellbore. The completion engineer needs to know the number of zones that are going to be completed. If there are multiple zones, like 3 or 2 or 4 zones that are to be completed, the engineer now, has to be considering whether or not to do a smart well, or to just, if it is just a single zone that we are looking at, then he now considers, doing a simple single zone dump completion. Then we also have the engineer needs to understand drilling. Okay, he needs to go back and understand the history of the well. Okay, when they were drilling the well, did they encounter issues? And issues can take the form of you having mud losses. Okay, mud losses into the formation. Now, anytime that mud comes into contact with the reservoir, a reaction takes place, and that reaction can plug the pore spaces within the reservoir and cause what we refer to as formation damage. So if before you even start your design, you are aware of any such damage, then you know that as part of your design, you need to do some form of stimulation to be able to treat the damage that has been left over from the drilling phase. You also have to know how the well was suspended. Okay, how many blocks, how many barriers were put in the well, what type of barriers are these? Are they mechanical? Are they cement plugs? Okay, each of these would require a different set of procedures and a different approach when you go in to complete the well. Sometimes after the well is drilled, accidentally tools can be dropped and left in hole, and it would mean that before I even start my completions, I have to do what we call a fetching job, which is basically to go down and recover any tool or BHA that has been left in the well from the drilling phase. So all these pieces of information, the reservoir information, drilling data, production data, they all, it's all put together by the subsurface team into what we call a statement of requirement. So the statement of requirement, or the SOR, would capture all these pieces of information. It would define the objectives that the completion is supposed to achieve, and it will specify any the production target, the production rate, and if there are corrosive fluids in the reservoir, the SOR will specify all of these. So the completion engineer uses this document as the starting point. He takes the SOR, all this information is in there, and he designs the well based on what he's been given in the SOR. So I put this slide here to show you how the completion engineer interfaces or works with other professionals to achieve his objectives. So it's not like the completion engineer works in isolation or is an island. I've spoken about some of the information that he works with, and this information would come from different professionals. It would come from different sources, and the completion engineer needs to interface with all of these professionals to understand the subsurface conditions, to come up with an optimal design. So interface with drilling geologists, reservoir engineers. He will interface heavily with the service sector. So the service sector, are companies that we work with, and these companies, they provide us with the tools, the equipment, they provide us with the chemicals, the fluids that we need for our job. So we interface heavily with them to procure these consumables or tangibles that we need. The completion engineer interfaces with specialists such as the metallurgist, and like I've explained, the fluid that Hello, can you hear me?
Yes, please. You're audible, Mr. Sumia.
Okay. Can you confirm where I dropped off? If the size is to determine the size of the tubing that you want to run. Okay. So if it's an oil producer, you need to size the tubing accordingly. If it's a water injector, then the rule of thumb is that the bigger, the better. So for a water injector, you want to use the largest tubing possible to allow you to push a lot of fluid from surface into the reservoir. And to be able to do this, the engineer has at his disposal special softwares that he employs in his job. So to carry out inflow and outflow modeling, he would have softwares like Prosper to do that. The engineer now also uses or does tubing stress analysis. So basically, once you put a well on production or injection, right, the movement of fluid from the reservoir to the Christmas tree or to the, let's end at the Christmas tree. The movement of fluid from the reservoir to the Christmas tree, because these fluids are coming, they are under pressure and they are at high temperatures, they put a lot of load or forces on the tubing. So the design engineer at this point has to run simulations to determine that he select tubings of appropriate grade and metallurgy to withstand all these load cases. And also he's determined the size of the tubing. The next question is, okay, will it be possible for us to run the tubing to depth? Imagine you have a very long hole, like 4,000 meters, and you are running sections of pipe into the hole. So the tubing comes into contact with the casing. It produces friction, or in oil and gas, what we call torque and drag, and it creates some form of resistance. So the engineer has to be able to model all the side forces and the forces, the contact forces acting on the tubing, to be able to determine that, yes, indeed, I can run this size of tubing down the well and there will be no holdups or restrictions. I've spoken about the metallurgy bit. Here we are looking at corrosion and erosion. Another key design consideration is the perforation design. And over here, the engineer now has to think about ways in which he's going to deploy the guns to depth. Is it going to be on slick line? Is it going to be on E-line? So E-line is electric line, or is it going to be on tubing or drill pipe? Then there is also the explosives. Depending on which sort of explosive you select, you would end up with either bigger entry hole diameters, or you could end up with longer length for the perforation tunnel. So you need to design the perforation in such a way that the size of the entry holes that you create on the casing is large enough and the tunnel is long enough to be able to pierce the casing, pierce the cement, and contact the reservoir to enable fluid to move from the reservoir to the wellbore. Then it comes to fluid selection. So here, based on the reservoir pressures and temperatures, you select fluid that it's of an appropriate weight and will give you enough hydrostatic pressure to be able to keep the reservoir pressures in check. Also, after you have perforated the well, because you've created a passageway, or you've now linked the reservoir and the casing, depending on the pressures at play, you could have fluid moving from the well into the formation, and you need to stop this. So at this stage, the engineer has to select or design an appropriate pill, which first of all will stop the downhole losses, and at the same time, the pill should be designed in such a way that it doesn't cause any damage to the reservoir, i.e. it doesn't plug the perforation tunnels that has been created. So on my right, you can see perforation guns which have been run into the well, and we've now detonated these guns, and the end result is that the casing ends up with a lot of small holes in them, which we call the perforations, and it is these entry holes that allows fluids to enter the wellbore. Now, once the engineer has completed his design, he compiles the result into a document, and this document is referred to as the basis of design document, or simply a BOD. So moving on to the next phase, the BOD will now contain very high level operational steps. It will contain the result of any calculations or any simulation that the engineer has performed, and it will now form the basis of writing the procedures that will be executed offshore. So the next stage of the well delivery process is called the planning phase. So at this phase, I'll touch on some of the roles that the engineer will perform. Like I said, depending on the size of the company, you could have one engineer who does all of this, or you could have dedicated engineers assigned to each of these tasks. So I'll start with what we call time and cost estimate. So over here, what the engineer is doing is that he calculates how long the whole operation is going to take. So he picks the BOD, he looks at operations that would need to be performed offshore to achieve those objectives, and he put a time or a duration to each activity, and in the end he comes up with a number. And to do this, the engineer uses offset data, or he uses past operations, information from past wells that has been completed. He also uses his judgment and experience a lot. After that, he now has to come up with a budget for the well. How much is the well going to cost? So depending on the length of tubings or which type of equipment is going to be run, he he costs all these individual items and generate, a lump sum for the project. Another thing that he does is that he takes the BOD, and from the BOD, he develops the BOD into a very detailed program. So a completion program tells you the means by which the job is going to be performed. So it's a step-by-step procedure of every single task that needs to be performed offshore to install the completion. Then at the planning phase, there is also a lot of planning and coordination. Over here, the completion engineer has to interface with the service company engineers, plan equipment, plan personnel, calculate, the volumes and quantities of consumables or tangibles that are going to be required. And the engineer is just not involved in only the technical aspect. He's also very much involved in the contract. So all these service companies who work for you, there is a contract, binding or defining the relationship between the operator and the service companies. And that relationship needs to be managed with a contract. And the completion engineer does a lot of these contract management at the planning phase. Then we transition to operations. So operations, this is where we carry out the installation. This is where we actually do the job, right? And over here, the completion engineer works as a supervisor. So he supervises people and ensures that they are following the procedures that have been outlined in the completion program and that they do not deviate from the program, right? He also supervises any testing that is required to be done offshore to ensure that procedures are being followed. So I'll quickly go through some of the key operational phases. I know when I started, I gave a very basic explanation, to how completion is carried out. And I know it may have come across as being very, very simple. Somebody would say, oh, this is easy to do. Well, it's not that easy. So basically, when we come onto the well, the first phase is the Christmas tree installation. So over here, we interface with the subsea engineers, that is Joseph and his team. They would come in and put the Christmas tree on the wellhead. Once that has been done, we enter the well, and if at this stage we recover any suspension barriers or plugs that was left behind from drilling. So basically, you take out all the barriers and you now have access to the wellbore. The next stage is the wellbore cleanout stage. Now, completions, what's the word to use? If you go back to the picture I showed about the perforations, you would see that the holes that we are actually making are very tiny. In fact, the diameter of those holes that you saw on the casing is about 0.3 inches. Some are even less. Some could be 0.2 inches. So what I'm trying to get out is that the perforations, which is basically the gateway to the wellbore, those perforation holes are very, very tiny. And because they are tiny, they can easily get plugged with debris. And this is a major operational phase. We have to ensure that before we start running equipment or tubings into the wellbore, our casing is clean with no debris, clean with with no cement in it. And we, at this stage, we run specialized equipment, brushes and scrapers to clean the inside of the casing. And once that has been done, we displace the brine that was originally in the well. We now displace it to a new well, to a new brine system, to make sure that the well is crystal clean, and that when we are running the tubing or the perforations do not get plugged with this debris. Sometimes we also carry out wireline logging. So we do this to determine the quality of the cement bond log. You remember I mentioned something about the drilling guys running casings and cementing the casings in place. So when we come in, we run these wireline logs to sort of confirm that indeed the drilling guys did a good job, and we have a very good isolation between the casing and the reservoir. If it is a multiple zone completion, we have to ensure that from one zone to the next zone, there is cement in place, which is isolating the individual zones. Then we move on to perforating, where we simply run guns. Once we get to the depth where we want to shoot, we detonate these guns, and these guns create holes inside the casing to allow access of wellbore fluid, or to allow access of fluid from the reservoir into the wellbore. Now, once we have perforated, perforation leaves debris behind. So the type of guns and the explosives that is run, once you fire them, the end result is that you can get these debris from the charges. So before we move on to the next stage of the operation, which is to run the actual completion, we do a second wellbore cleanup, just to make sure that we are not leaving any perforating debris behind. And sometimes too, depending on the strength of the rock, when you shoot, the rock disintegrates, and you have these fine rock particles moving into the wellbore. Now, these fine particles, they can cause the tools to malfunction. And the objective here really is to do a second wellbore cleanup, remove all these debris from the wellbore, and once again, displace the well to a clean brine system. Then we go to the installation itself, where all that we are doing is running a joint of pipe. Okay, running joint of pipe into the wellbore. Now, a joint of pipe is roughly about 11 or 12 meters. So depending on the length of the well, we screw so many pieces of tubings together to form one long tubing. And at specific depth, we have specialized tools and equipment that we make up to the tubings and run them in hole. Then once the completion has been run, the packets are set, we test our completion, to ensure that, yes, it is forming an envelope, right? And that there are no leaks on the completion, and that the completion is fit for purpose. If we run specialized equipment or tools into the wall like gauges, at this stage, we have to make sure that all these gauges and equipment, they are working as per the design, and they are good to go. Now, once we've done that, we do what we call a flowback or an injectivity test. So at the initial stages, the reservoir guys and the production guys, they came up with some predictions. They came up with some estimates. Okay, we expect this well to produce 10,000 barrels of oil per day. We expect it to produce 8,000 barrels of of oil per day, right? So once we are done with the installation, we need to confirm, okay? We need to confirm the performance of the reservoir. How much can we actually produce from the well? How much can we inject, okay, into the well? And that is the flowback or the injectivity testing. So we test the performance of the reservoir to see if it is as per what was outlined in the statement of requirement. And finally, when everything is done before we leave the well, we do our final test. We test our Christmas tree, which was installed at the very beginning. We test all the valves and make sure that it's working fine. And once we are happy with the result, we hand the well to the production engineers. They now take the well and they produce from it in an optimal way. Now, in all this, right, the number one objective really is safety. Okay, so during the design, during the execution phase, safety is key. And we want to deliver a well which is fit for purpose. And we don't want to cause any damage to the environment. We don't want to cause any damage to personnel. We don't want to cause any accident or incident on the rig. So the number one objective here is that we want to execute our operations without causing any EHS issues. So the life cycle of a well. At various phases of a well, the completion engineer can take on different titles or names. So the purpose of this slide is that it's still the same engineer, okay? It's still the same engineer, but he's now working in different capacities. So at the exploration stage, right, the completion engineer can work as a drill stem test engineer or a DST. Now, the DST is a temporal phase where you are doing your exploration, and at this stage, maybe it's a new field, right? It's a new field. So once you haven't started with development, you want to confirm the performance, of the field. And to do that, you first of all drill exploration wells, and you do initial well testing to determine the capacity or the performance of the reservoir. Now, the type of completions that you run there, because it's at the exploration, okay, the type of completion is temporal. After the exploration, you can retrieve the completion, or what we call a DST string. We retrieve it from the well. So the design considerations that goes there is different from when you are designing for the life of the well. So if I'm designing a completions which is going to last me a month, right, there is no point to putting very expensive equipment in there, right? So that's the DST engineers. Then we come to the development phase, which I have discussed, in the previous slide. Then once we hand over the completion to the production engineers and they are managing the well, from time to time, they encounter problems. You remember, we run so many tools into the well. So at some point, some of these tools can malfunction, right? Say gauges can stop working, and you are not getting any readings from your gauges. It could be your sliding sleeves, or it could be your interval control valves, okay? They are supposed to open to increase rate or reduce rate. These ICVs or interval control valves, they can get plugged with debris. And when these happen, you need to go back into the well and fix the problem. It could even be a recompletion. you designed your completion based on an initial set of data. Now, after producing the well for a long time, you can find out that, the size of the tubing that you put in there, because the reservoir pressures have declined, you now have to go back, retrieve the old completion that was in there, and install smaller tubing sizes. So this phase is called the workover, the intervention, or the recompletion phase, and it is still the completion engineer at work. And finally, when the well reaches its end of life, we want to abandon it. By abandonment, we are installing plugs into the well bore to make sure that the reservoir is isolated and to make sure that we have a minimum of 2 barriers in place to prevent hydrocarbons from flowing uncontrollably to surface, and that is abandonment. So in all of these phases, the completion engineer is involved. He may take on different titles, he may take on different roles, but it's still the completion engineer at work. Then finally, I want to talk about career options. So as a completions engineer, you can work in the office, okay, designing and planning wells, or you can be offshore or in the field, okay, supervising project. You could work with an oil and gas operator like Tullow, like ENI, like Chevron, like Shell, or you could work with a service company. You could also work with government institutions like the Petroleum Commission or GNPC, or you could go into academia and be a lecturer and help train, young professionals who want to enter the industry. Or better still, you could set up your own private consultancy where oil companies will now come to you to provide solutions for them. And some of the key skills that you need as a completions engineer is project management, of course, because of the number of people that you encounter, right? You need to develop your project management skills. You also need to learn how to supervise operations. You are involved in budgeting and costing. You need to develop special skills in modeling reservoir or wellbore conditions. You are heavily involved in contract management. You are a safety leader. And as a completions engineer, you get to travel the world. You get to meet and work with people from all races, all cultures, all backgrounds, people with very different views. And the bottom line, this career is highly rewarding, and you will be greatly compensated for the effort and for the work that you put in. And that brings me to the end. Marvin, over to you.
Thank you very much, Mr. Enoch, for the wonderful presentation. Quite an elaborative one as well. And so you highlighted a lot of key information and a lot of technical information for us as well. We found out how that some of the roles depend a lot on each other, especially reservoir data and the integrity of the well. And then we also saw that we need to ensure that we have environmental health safety concerns as well as part of each of our projects as well. So thank you very much. I'm sure we'd have as we move on to the next session, we'll be able to highlight some of the key areas you mentioned in the latter end of your slides as well. So we would like to move on to the next session. We are going to have a cross-questioning session where we ask some key questions to our distinguished speakers. And so I'll be doing the questioning. And so at this point, each of the speakers, Mr. Enoch or Mr. Joseph, you are at liberty to pick up the questions and answer them as they come about. Thank you very much. So to our first question, I want to ask this question that we are highlighting. The cross questioning is going to highlight 4 key areas. We are going to look at distinctiveness of each of the roles. We are also going to explore how some of the roles collaborate with each other, some of the challenges we experience, and then also finally some future career opportunities as well for young professionals and students alike. And so the first question we want to, the first question would be that what are the key skills or competencies that define your roles that has to do with subsea and well completions alike? And how do they contribute to a project success? How do they contribute to a project success? And then it's a three-part question. So the final question that adds up to it would be, what would be your key performance indicators, or what we call performance metrics, that enable you to have a a successful project? So I'll repeat the question again. What are the key skills and competencies that enable you to have a successful project? And also, what how unique would be your role to other roles within a project that contribute to the success? And then the follow-up question will be that what are some of the key KPIs or key performance indicators that distinguish your project success from your fellow colleagues as well? Thank you very much.
Okay, so Marvin, yes, that's the name. Uh, I'm always careful when I'm answering this question because we're dealing with, it depends on who you are speaking with. I can see we have a number of students, people who are in the early stages of their career on the call. And sometimes they get overwhelmed when they see the breadth of experience that we've amassed over time. So I'm always conscious of that when I'm answering this question. I would say this to the young ones who are on the call. Well, not to say that I'm old, but the first thing that you need, if it's an engineering field, the first thing you need is an engineering degree. You need an engineering mind. You should be able to. You should be someone with very vivid imagination. For me, when I talk about subsea, basically I say one thing: your imagination basically becomes your limitation. I was trying to share my screen, but I got overwhelmed. With so many screens here, so I didn't know what I was doing. Marvin, I'll try again, and you let me know if I got it right this time. Do you see my screen though?
Your screen is visible, please. You can share it.
Okay, so I'm not sure which of the screens you are seeing.
Introduction to subsea. That's
okay, so you see the field layout.
Yeah. We do.
Enoch did a very brilliant job talking to you about everything in the well. What you're seeing here, it's basically for Jubilee as an example. This is a Jubilee field layout, and you see all these lines here. They all represent something really interesting. The green lines you see are all the oil gathering system on the seabed. The blue ones are your water injection system. The red one in the layout are your umbilicals, and both the main umbilicals and then the infield umbilicals. And then you see the red line at the very top. That is your gas export line going to GNGC. Now, all you see here, what you are seeing here is, I'm trying to give you an appreciation of the size of a field of this nature. These are kilometers, like several kilometers apart. And I'm not talking about 1 kilometer, 2 kilometers. These lines are pretty long. So that gives you an idea of the magnitude and the size of kits that we play with. The reason something of this nature is important to the young ones is to let you understand that when you actually come into this space, number one, so long as you are open to learning, you are open to development, you have a curious mind, you will be given the tools that you need to actually excel. When Enoch's profile was being shared, there was one line in there about this completions training. Enoch, forgive me for not remembering the exact name of the training, but in this training that these drillers and then the completion guys go for. Basically, every company, at least every good company that you join, will give you the training that you need to excel in your role, the training that you need to develop, and then the training that you need to be able to actually deliver on the various projects that they have. You see here different pictures of different projects. There are so many different things that you see in this picture here. On the extreme left is exception pile. So in the layout that you saw, you have, let me go back so that this will make sense to you. So if you take, for instance, I don't know if you can see my cursor, which I doubt, but in the layout, the green line, you look at the structure there, that is a manifold. and the various wells are connected to that manifold. So flow from each well commingles in the manifold and then together flows in a line going to the FPSO. Now, if you move to the next picture that I'm showing you, you see that cylindrical structure being deployed into the water column. That is an example. That is a suction pile as an example. Depending on the type of seabed that you have, your manifold may be stationary and stable on the seabed, but then if you're dealing with very soft seabed, then you need a foundation for it. So that's an example of a suction pile. It sits on the seabed, and then your manifold sits on top of that, and it keeps it stable for you. The second picture, you see a jumper there. I talked about the wells being connected to the manifold. That is a piece of pipe that connects your well to the manifold. The beauty of this is these words that I'm mentioning, if you jot them down, you go on YouTube, you Google them, you'll see so many different videos and animations that would explain them to you. So you don't have to try to memorize anything that I'm saying here. The picture on the left bottom, that is an example of a Christmas tree being deployed for installation. The one in the middle there is a choke that is being replaced. The one there was faulty. Remove the faulty one, put a new one in. So different things going on in this space. You move here, these are some of the supports that happens onshore. The fabrication of the jumper itself prior to it being sent offshore. You have your, these flying leads, interesting names for them, but you know, the umbilical is the means by which you have your hydraulic, chemicals, fiber optics, electrical signals being sent from the top side to your subsea infrastructure. And then these ones that you are seeing are only for hydraulic and chemicals. So you have, steel tube flying leads, SFL, will handle your hydraulics and chemicals. You have your electrical flying leads, EFLs, that will handle your electrical connections. If you do have fiber optics in the field, then you also have one, or you can even integrate your EFL with your fiber optics, depending on what you have in the field and what you're trying to do. So once again, the limitation is actually your imagination. There are so many different things that you can come up with in developing your field or solving a problem. If you look at this picture, for instance, a suction pile and a manifold being fabricated, some of the kits that come together to make these structures that go subsea. So I'm trying to give the young ones who are on the call a glimpse of some of the things that you see when you are actually in this space. This particular one is for production support. So the guys who sit behind the computers, monitoring the parameters from both the subsea equipment and then the topside equipment. And then so long as any of these parameters begin to drift off, we have to troubleshoot, find out what is causing the issue and then immediately resolve it. So there are so many different things. And then you go on to maintenance and integrity and the various testings that are done, ensuring that your structures are adequately protected, cathodic protection from corrosion, because I mentioned earlier on that you are dealing with very corrosive environment, seawater. So you need to ensure your structures are protected, your anodes, if they are either depleted or you don't have electrical connection, your structures begin to corrode. Some of the pictures you see, they're testing the annulus of the risers to ensure that they are not being filled faster than they are designed to. Whenever we get opportunity of recovering any of the subsea structures, we actually subject them to a lot of testing, just so we understand, and then we're able to extrapolate the health of the other structures on the seabed. So this is where the subsea maintenance and integrity guys, some of the activities that they perform. So slide I'm sharing there, so I'll stop sharing now. So Marvin, to answer your question once again, for the young ones, what do you need to actually excel in this space? Well, you need to pay attention in school. That's number one. Paying attention in school is not about getting a first class. And I'm not saying first class is bad because I got first class myself. It's good, but that is not what we're talking about. What we are talking about is actually learning something vital from school. Your basics, your basic engineering, you need to be on top of that because they will all come to play when you're actually in this space. What's the other question? Forgive me, I'm growing old now, so.
Yeah, so Mr. Joseph, so the other question was, how unique does your role contribute to a project success, and what are some of the performance metrics that you measure your success with in your field?
So success, number one, ensuring that for every project, right, you have the project goals. HSE, health, safety, and environment, ensuring that nobody is hurt on the job. The environment is not impacted negatively by what we do. Then you also have the cost. So now we're talking about projects, that's the KPIs for projects. Every project has a budget. So you need to ensure that you actually stay within your budget and you don't blow the budget. Your project goals, you need to ensure that if your objective is to design a field that will end up producing X thousands of barrels, you're actually able to deliver the project to the project goal. So those will be the KPI, general KPI for a project. Now, if you start talking about for employees, that becomes a little bit different, and it's different for every discipline. So this is where you'll be sitting down with your line manager and then agreeing what the department's objectives are, and then cascading down to the objectives of everybody in the department. Because this particular industry, this is an industry where we all work in teams. Teamwork can never be overemphasized when you're in this industry. So if you are not a good team player, you do not work well with people, you always struggle in this industry. That is a very important one. So it's a skill that everybody needs to learn. You need to learn how to work with people and work in teams. Enoch, I don't know if you have anything else you want to chip in for that.
Yes, Joseph, thank you. I think, you've covered it all. You've covered the KPIs. What I wanted to add really is on the soft skills. Most of us on this call are graduates, and from the technical side, that's really all that is required. Once you are a graduate, you've graduated from a recognized university, you can enter into any of these fields and excel. What would really set you apart now is the soft skills. And by soft skills, you are looking at interpersonal skills. When you are put under pressure, when you have to deliver tight deadlines, how do you relate, with people? Your communication skills, presentation skills, report writing. These things are invaluable, and if you really want to excel, you have to focus on developing these soft skills. And another key skill that you also have to develop is attention to detail. Now, these projects are capital intensive. The operators and their partners have put in a lot of money. So as an engineer, you can't make a mistake, right? You can't make a mistake. You have to double check your numbers. You have to make sure that you've gone over your work, and there is no room at all for making mistakes. And that is all I had.
Thank you very much. Thank you very much, distinguished speakers. Thank you for your submissions. To our next question, we would like to find out, are there any role misconceptions about the role? So we realize that most YPs or young professionals enter the industry, and it looks as if because they have a degree, or some of them are engineers, they might get promoted straight away to certain high level roles. So we want to know some of the misconceptions around getting into offshore, subsea, and well completions as well. If you've experienced any, thank you very much.
Okay, so there's one very obvious one. Please, if you are new and you are coming into this industry, beginners, most of the time, you do not make rockstar wages as a beginner. It's very important that we manage expectations. Now, as you develop yourself, so your skill sets, your experience makes you more marketable, good money. So please, just so beginners, you manage your expectation. Do not expect that the moment you get a job with a company like Talo or ENI, you begin to make the kind of wages that Kudus and Thomas Partey make. please, let's manage those expectations. So that would be the first misconception that I will give to all the beginners. With the job itself, you see, most of us on this call, our parents are civil servants, myself included. And in the civil service, promotion is with seniority, number of years on the job. So the longer you stay on the job, basically your promotion mirrors the number of years experience you have. In this industry, promotion actually mirrors your performance. So you may be on the job for 5 years, someone else may be on the job for 3 years. The person may get promoted ahead of you. It's not about favoritism. So we should all be mindful when we are actually coming into this space, that this space is heavily heavily performance-based and not just longevity.
Yes, I would want to add that, and I'll speak from my own experience. A young engineer, getting started with Talo, after doing all that calculus and all the engineering math in tech, right? When I entered the industry, I had wild ambitions and goals. I thought that as soon as you enter, you get handed responsibilities, you get to work on project, and but I found out that most of the jobs that I was initially given were around report writing, they were around compiling data. And those days I would ask myself, so is that what I'm good for? I have gone through this training from tech, and I expect to be doing real job, and I'm here compiling data, I'm here writing report. But what I found out later on was that because I was into data gathering, okay, it made me appreciate the sort of information I was working with. I understood the data, and some of the reports that I wrote over the years, I found out that no, it really enhanced my report writing skills, and these are all key. So the advice here is that when you start fresh, know that it takes time, right? It takes time to develop, and take every task assigned you, take it seriously, do it to the best of your ability, and always aim for perfection in the very little things that you do. And as the years go by, you would see the result yourself.
Thank you very much, Mr. Enoch and Mr. Joseph. We appreciate your wonderful contribution. So our next question will be something around collaboration and how some of these roles interact with each other. So we want to ask, how do you bridge the gap between you being, we had a seminar, a webinar some time back, and we're looking at generalist versus specialist, being specialized and being a generalist as to different aspects, combining you yourself being a manager as well. So I'd like to ask, how are you able to combine being a generalist, or let me say being a specialist in an area, and then some of your colleagues also specializing in one area? How do you bridge the gap and merge towards a project success? Thank you very much.
So when you say someone is a specialist, right, it does not mean that you know so much about one area and ignorant about everything else. No, that's not what a specialist is. And then if you look at and it also depends on the role that you are playing. So you go to the service providers or the contractors as an example. If I look at my past life before joining Talo, you can have someone who is a structural engineer and his entire job is design. He sits behind a computer. The project engineer comes and then says, okay, I need to design this structure, and these are the operating parameters, these are the environmental conditions. And then he goes to work. He sits behind his computer, crunches the numbers, build a model for you. He shows you what it's going to look like. The project engineer provides his comments. Everybody's okay. He spits out his final drawing, and then he goes to the draftsman. And then the next one comes to him. such a person has specialized in structural engineering. Then there's someone else, his primary job is installation engineering. You come in with the vessel you're going to use for your installation, the various equipment on the vessel, your installation aids, all your parameters, and then he goes out there, builds a model, simulates the stresses you're going to see in your structure, and then he spits the results to you. He gives you the conditions under which you can safely install the structure. He is a specialist. Now, if you take that project engineer who is interfacing with the structural engineer, the analysis engineer, the draftsman, the design engineer, dealing with the cost engineers, the contract guys, the schedulers, that person can very easily be termed as a generalist. So it depends on your role. Of those guys who is just focused on one area. But this will be my general advice. Even if you happen to find yourself in an organization where you are being people are also doing, it helps a lot. I say this all the time. I didn't choose to become a subsea engineer. Subsea engineering chose me. My bachelor's is mechanical engineering, master's petroleum engineering. When I was doing my master's, I wanted to become a production engineer. My second option was drilling. I didn't like reservoir, too much abstract and modeling. That's not my thing. But right after school, I ended up in subsea, and it's been 16 years since then. So for me, I'll tell anyone who is actually working in, if you want, talking about should I become a specialist or a generalist? Sometimes you don't have the luxury of choosing which one you want. The opportunity available to you will dictate where you go. But if you find yourself in a situation where you are being pushed into a specialist, do not only narrow yourself to only what you are being exposed to. Make it a conscious effort for your own development to expose yourself to other people's areas. So when you happen to sit in a room with everyone else and you're having a conversation, you're able to understand what others are saying, and you are not basically just boxed into just your one corner.
Thank you very much, Mr. Joseph. And Mr. Enoch, would you like to add up to his submission?
Yeah, so Joseph has covered it all. Usually, when you start off, you would begin with a specialist role, and you find out that as you climb the career ladder, the role now becomes more managerial, and it now becomes very general. And once it gets to that stage, your understanding and appreciation of the other disciplines, now becomes key. So what I would say that when you begin your career, of course, focus on your technical area, but also speak to friends, understand what they do, understand the kind of data that they work with, understand how their work impact what you are doing, get the overall, big picture. And this, will come in handy when, as you move up the career ladder and you assume more managerial roles.
Thank you very much, Mr. Enoch, for that wonderful submission. And we are hard pressed with time, so we'd like to ask one final question before we move to the Q&A session. We want to ask that how is the with the emergence of green technology and the whole AI and all of these trends that are coming up, what should this let me say young professionals or even those in school what should they really be preparing for, considering subsea well completions and even the oil and gas industry at large? Thank you very much.
I love because this green transition, green energy, anti-fossil is an interesting conversation that I don't think is going to end anytime soon. The reality is this: can we, and especially those of us in the developing world, can we afford to say that we want to or we can move away from fossil? I don't think the answer is yes. So yes, green transition will be there, green energy will be there, environmental sustainability will always be there. If anyone gets the opportunity, you can learn a thing or two in these spaces, but fossil fuel is not going anywhere, especially not in this part of the world. So if you happen to be, in school or about to start your career, and oil and gas is what your interest is in, don't get deterred by all the news you hear about transitioning from fossil fuel to green energy. Because if you pay attention, you realize that some of the majors who've been championing green energy in the past few months have been backpedaling a bit. So it's a very controversial topic. I try to stay away from controversies when I'm in a public space like this. But then I'll say oil and gas is not going anywhere, at least not in our lifetime.
Very much. Thank you very much, Mr. Joseph. Mr. Enoch, would you like to add up to his submission as well?
Yeah, so I would like to talk about the artificial intelligence aspect of it. So as a drilling or a completions engineer, you are looking at a lot of data. You are trying to identify trends. You are trying to look at the similarities, between data sets. You are analyzing offset data on a daily basis. So being equipped in tools such as AI, such as Power BI, it makes your work easier. Okay, you are able to perform advanced data analysis. You are able to do data mining in very fast, and it also helps with presenting your data and the interpretation of data. So I would say that, yeah, once in school, if there is any opportunity around you to attend a training or take up courses in Power BI, in AI, by all means do that, and it will come in handy when you join the industry. Thanks, Marvin.
Thank you very much, Mr. Enoch and Mr. Joseph. We are hard pressed with time, and so unfortunately, our Q&A session would have to be postponed or for another time. But we have an upcoming webinar at 3 p.m. that is coming up at 3 p.m. And the webinar is, what the webinar is about is we are exploring Ghana's petroleum downstream sector that has to do with driving growth and innovation and sustainability. And also under the career guide section, we have another webinar coming up that has to do with driving sustainability and energy security in Ghana's oil and gas industry. So once again, thank you very much, Mr. Enoch and Mr. Joseph, for your wonderful submissions. We actually learned a lot of technical information, and we are so happy to have had you join us this afternoon. We want to proceed and take the vote of thanks from Miss Natalia as we round up our session for this afternoon. Miss Natalia, if you are available, you can kindly share. The floor is yours. And please kindly remember to fill the feedback survey in the chat box as well so that we can make this meeting better next time.
All right, Engineer Marvin. I'm honored to be part of this occasion and grateful for the opportunity to learn together. So I extend my sincere appreciation to the organizers for their initiative in enhancing our understanding of subsea engineering and well completions. And also a special thank you to our esteemed speakers, Engineer Joseph Pongo and Engineer Sohumia Ada Enoch, for sharing their valuable insights, which have greatly enriched our knowledge. Lastly, I would like to express my Gratitude to our audience. Your participation made this webinar a success. Thank you all and have a wonderful day. Engineer Marvin, over to you.
Okay, thank you very much for joining. Thank you, our esteemed speakers, once again. Thank you, Ms. Natalia. Next webinar, kindly make sure you join us, and remember to renew your SP membership as well. And if you're not a member, you're free to join SP as well. Thank you very much, and thank you, everyone. Have a wonderful afternoon.
Thanks, Marvin. Thanks, everyone.